This is 7-1, adding and subtracting polynomials. Your objective is that you're able to add and subtract polynomials. To start off with, in exercises 1 through 3, we're going to find the degree of the polynomial. A degree is the highest power, or if you don't know what that quite means, you can think of it as your biggest exponent. So to start off with, number 1, we have 7n to n, not m, to the third. And so my degree on this is 3, because the 3 is the highest power, is the highest exponent. Number 2, we go 1 over 3x to the fifth. This degree is 5. Number 3, we have w squared y to the fifth. This degree is also 5, because we're looking at that highest power on that. In exercises 4 through 6, write the polynomial in standard form, identify the degree and leading coefficient of the polynomial, then classify the polynomial by the number of terms. So to classify, and this is talking about the number of terms, we have a couple different things. And a term is kind of a set of number, if you will. And we're kind of going to get into a little bit of what a term is. But just so you know, what we're following is we're following some of the standard prefixes. So we have monomial, which is 1. We have a binomial, which is 2. We have a trinomial, which is 3. And you can imagine we just kind of keep going from there. So to start off with, standard form, I guess we should also talk about standard form. Standard form is ordering terms from highest degree, from highest to lowest degree. And so whenever we start this, we're going to be doing this for each one. Let's look at number 4. Number 4, we have 5h minus 4h to the third minus 2. Now in ordering these, we first need to get these in standard form. And to get this in standard form, what we need to look at is we need to look at the different exponents. So we're going to need to look at this one, and there's actually one here, but we don't really talk about that ever. So to start off with, I say, hey, this negative 4h to the third, that's the highest degree. So I need to go to, that needs to go to the front. Then I look through and I say, hey, this one has an h, and so I change that to plus 5h. And this one, this 2, actually has an h to the 0, we just never talk about it. Oops. And so at the very end is our negative 2. Next thing that it wants us to do is it wants us to identify the degree. The degree on this is that highest power, so it's 3. The lead coefficient, the lead coefficient of this is negative 4. It's the number that's with your highest degree. So I get this from this negative 4 right here, because it's the number, the coefficient that's with that higher degree, that higher power. All right. Oops, we're not done yet. Getting excited. Then classify the polynomial by number of terms. And so to classify the polynomial, I look at how many terms it has. So this whole kind of setup here, where we have a coefficient and a variable with a power, is a term. And then this is another term. And then this is another term. So I have 3 terms. So terms I have 3, which means it's a trinomial. Okay. Let's look at number 5. Number 5 is 10 plus 4p cubed. So the first thing that I need to do is I need to rewrite this in standard form. So standard form, it goes by the degree, so it's 4p cubed plus 10. And I'm just moving these around because of the communicative property, where I can kind of just move things as long as I keep the what's happening with this the same. The degree for this is 3. The lead coefficient is 4. And the term, or the terms, I look at it and I go, there's 1, there's 2, so I know there's 2 of them, so that tells me that's a binomial. Alright, let's look at number 6. Number 6, we have 6v to the 7th. This is already in standard form. The degree is 7. The lead coefficient is 6. And the terms, I only have 1 term, so that tells me that's a monomial. Mono meaning 1. Okay. Alright, moving on to number 7. In number 7, 7 through 10, sorry, we are going to find the sum. And it's kind of, it can be tricky if you're not really paying attention. But if you kind of take that extra second to kind of work through, okay, what's going on, it makes everything work so much easier. So, the first thing that I kind of, whenever I'm looking at these, the first thing that I notice is I'm like, oh, man, it'd be really great if those parentheses were gone. Now, your first set of parentheses, assuming nothing's to the left of it, you can kind of just drop the parentheses right off the bat. And so you have 4t plus 6. Now, where people get mixed up is this kind of inside part right here, what's happening here. We're going to get to a point a little bit later where we're going to have a subtraction here. And so what that does is that changes the sign. But because this is an addition, we're going to keep the signs that are happening inside of the parentheses the same. And so we're going to have minus 4t minus 2 because we have that negative 4t right here, and we have the negative t right there, and that plus kept everything the same. Now, this might start looking a little bit more familiar, and what we can do and what we need to do is we need to combine like terms. And so maybe I'm going to take a second and say, okay, what are the like terms? Okay, I have a 4t and a negative 4t, and I have 6, and I have negative 2. And so I'm going to start combining those. So the 4t and the negative 4t makes 0t. If you want the 0t, you can. You don't have to. So then you can just set this to be 6 minus 2, and so 6 minus 2 is 4. And maybe I write out 0t minus 4. Or, oops, plus 4. And we get that. Alright, number 8. Negative 12v plus 3 plus 8v minus 7. Okay, so again, I'm going through and I'm going to say, man, I really want to get rid of those parentheses. There's nothing happening to the left of the first set of parentheses, so that tells me, okay, I can just drop them. Plus 3. This is a plus, so that means all the signs are staying the same. That's a positive 8, so that's a plus 8v. And that makes this a negative 7. I need to combine like terms, and so I say, okay, I have negative 12v, and I have 8v, and I have 3, and I have negative 7. Okay. So 12v and 8v, or negative 12v and 8v makes negative 4v. 3 and negative 7 makes negative 4. And so that's my final answer. Feeling good? All right. Let's take it up a level. If I have 3j squared minus 7j plus 1, and I add negative 6j j squared minus 4j plus 9. This one looks a little bit more complex, but the reality is nothing's really changed. The only thing that we added in was we just added in a new term and a new variable with an exponent on it. And so what that tells us is we're still kind of looking at these parentheses and being like, man, it'd be really great if they're gone. And there's nothing happening to the left, so I say, okay, 3j squared minus 7j plus 1. This is a plus in the middle, so that means I just kind of continue on. I keep the signs the same, so I have negative 6j squared minus 4j plus 9. All right, so I'm going to go through and I'm going to find my like terms. By this time, hopefully you kind of understand this idea that these j squareds and the j's are actually different terms. So this 3j squared can only combine with this negative 6j squared. And that's where I see a lot of people kind of mess up, is they go, oh, I'm going to combine this 3j squared and this negative 7j. You can't do that. They have different powers, so that's kind of the big indicator. And so I have this negative 7j and then negative 4j, and then I have 1 and I have 9. So I start combining like terms. So I go 3j squared minus 6j squared is negative 3j squared. All right. Have I taken care of all the j squareds? Yes. Okay, now I move on to my next term. I go, okay, negative 7j minus 4j. It's going to give me negative 11j. Have I taken care of all the j's? Yes. Okay, I can move on to the next thing. So I go 1 plus 9 is 10, so plus 10. And that's my final answer. All right, let's look at number 10. So 2w squared minus 7w plus 3 plus 2w squared plus 8w. This one is a little different because if you look it up, you look at it, you go, okay, there's 3 terms on the left and only 2 terms on the right. How can we do that? And the way that we do that is actually no different than what we've been doing otherwise. So the first thing I do is, okay, there's nothing to the left, so that tells me, all right, 2w squared minus 7w plus 3. All right, the plus makes everything keep the same sign, so all right, 2w squared plus 8w. All right, going to look for those similar terms. All right, 2w squared, cool. Negative 7w, positive 8w, cool. 3, and there's nothing else that doesn't have a w with it. If you kind of need something to imagine, you could say, oh yeah, there's a plus 0 over here, but that's not really necessary, and you'll see why here in a second. So we go, okay, 2w squared, that makes 4w squared. Negative 7w plus 8w makes 1w. If you need to put the 1, you can. Not necessary, though. All right, I've taken care of everything with just a w, and then I'm left with 3. So that's a plus 3. And so nothing really changes. That just stays as it is. And it doesn't have to be just if it doesn't have a w. Like, if it was, we had a w squared on one side or in one set but not the other, same thing applies. We're just combining them. We're combining the like terms. And that's as far as we can go. In exercise 11 through 14, we're going to be finding the difference. All right. So these are pretty much look the same, p minus 5, except instead of in the middle, we have this negative sign. And this is, again, this is the part where I find a lot of students start messing up, is they put it in the wrong location. So I start on the left, and I go, okay, there's nothing there, so this set of parentheses can just kind of disappear. Now I have this minus here, and what that does is that kind of distributes to both of these. We did it with the plus, but we just didn't really talk about it because there was no real reason to. So we have minus 4p plus 7. So we just change the sign of what's going on in the inside of that parentheses. I'm going to combine like terms now, so I get negative 3p plus 2. And maybe I should have underlined that for you. The p and the negative 4p, the negative 5, and the 7. All right, let's look at number 12. All right, so I have 8w plus 3 minus 9w plus 6. All right. Again, we're going to start looking through this, and I go, all right, 8w plus 3. Okay, I'm going to do, I just drop the parentheses because there's nothing to the left. This minus changes the sign of everything on the inside, so I go minus 9w minus 6. Now I'm going to start combining like terms. And so if I need to do that kind of underlining, I do. I say, okay, I first start with the w's, then I'm going to do the ones that don't have a w. So 8w minus 9w is negative w, or negative 1w if you need. 3 minus 6 is negative 3. All right, let's go to number 13. 3y, not w, squared minus 6y plus 9 minus 6y squared minus 7y minus 2. Now again, this looks really intimidating, but the reality is it's not changing much. The only thing that we're doing is we're just kind of adding another term on there. And I mean, as we kind of seen before, that doesn't really add too much. So look to the left, nothing there. All right, so I got 3y squared minus 6y plus 9. This negative is changing the sign of everything that's happening. So I get negative 6y squared plus 7y plus 2. Now I'm going to combine like terms. And so I go, okay, I got the y squareds, I got the y's, and I got the constants. So, and sometimes people like to do this one step at a time. They don't underline or highlight or anything like that. They first focus on just the y squareds, then they focus on just the y's, and then just the constants. And that might be like if you don't have a highlighter or something like that. So I go, okay, 3y squared minus 6y squared is negative 3y squared. Negative 6y plus 7y is 1y, so just plus y. 9 plus 2 is 11. All right, let's look at number 14. So we have 5b squared minus 6b minus 9. That's subtracting negative 2b squared plus 8b minus 1. So again, I'm going to look to the left, and I go, okay, 5b squared minus 6b minus 9. All right, I have this negative. It's going to distribute out. So I have plus 2b squared minus 8b plus 1. All right. 5b squared plus 2b squared is 7b squared. Negative 6b, negative 8b, negative 14b. Negative 9 plus 1 is negative 8. I guess one thing that I have also seen people do is once they use something, they scratch it out. So then they know, okay, I used all those. That's kind of hard to do with people looking at your notes afterwards because they're like, why'd you cross those out? But if you just kind of get in that habit as you're going through, it'll really help you out a lot. All right, number 15 asks us to describe and correct the error in finding the sum. And so this group starts with going, okay, I guess the problem starts with x cubed minus 8x plus 2 plus 3x cubed plus 7x plus 6. And for purposes of me, I guess I'll just write through how they did it. I'll probably accidentally be like, why did they do that? So x cubed minus 8x plus 2 plus 3x plus 7x plus 6. That equals x cubed plus 3x cubed minus 8x plus 7x plus 2 plus 6. I see that equals 4x cubed minus 15x plus 8. And you might be wondering, why did these things get put inside of parentheses? It's kind of another way of approaching it. Instead of kind of like crossing this out, or kind of what I've been doing before, you can set each thing inside of a parentheses. So this one, the 14 would have been 5b squared plus 2b squared, close it, and then we go plus negative 6b plus negative 8b, oops, yeah, plus negative 8b, sure, we'll just go with this. And then we do plus negative 9 plus 1, and then we combine them all and we'd get the same answer that we got before. Maybe you see it, maybe you don't. The place where they went wrong is they added a minus in there randomly. And you probably didn't even need the context of what was going on here. You should have been like, hey, wait, something's not quite right, because this 8 in here should have had the negative on it. So that's where they went wrong. All right, number 16. All right, in exercises 16, 17, we're going to find the sum or difference. So we go 3p squared minus 6pq plus 7q squared, p squared minus 5pq plus 9q squared. Alright, so in this case we're going to be finding the difference, and I know as soon as I wrote out that it had p, q, and q squared, we're suddenly having different variables. Some of you started going, oh my gosh, what's going to happen? But really what we're doing here is we're just combining like terms still. So I look to the left, okay, there's nothing there, so I just drop the parentheses, so 3p squared minus 6pq plus 7q squared. With this one, this negative is going to distribute out, and so I get minus p squared plus 5pq minus 9q squared. So in looking through this, I say, okay, I am going to combine like terms. And so I start with my 3p squared, and maybe I'll do the little parenthesis thing that they did up there. So I get 3p squared minus p squared. Anything else with p squared? Nope. I close it. Alright, then I'm going to do a plus. Then I'm going to find my next term. And some people like to try and focus on specific ones. I kind of just go the next one in line, and then I might adjust based later. So looking at this, okay, I got negative 6pq plus, oops, I'm going to scratch that out, 5pq, and that's all the pq's, so then a plus, and then I go 7q squared minus 9q squared, and that's all the q squareds. So now I'm going to combine like terms, so I get 2p squared, that makes minus pq, and that makes negative 2q squared. Alright, 17. X squared minus 4xy plus 9y squared plus negative 8x squared plus 6xy minus 9 or minus y squared. We're going to again kind of go through, make sure nothing happens. I need to drop these parentheses, so I get x squared minus 4xy plus 9y squared minus 8x squared plus 6xy minus y squared, because that plus didn't change anything. Combine like terms, x squared negative 8x squared gives me negative 7x squared. Negative 4xy plus 6xy gives me positive 2xy. 9y squared minus y squared is a positive 8y squared. All my terms are combined, and that means I'm done. In ideas of standard form, kind of choose a variable and run with it and go in order of that variable. So I always start with my x squared, or not always x squared, but I always choose one of my variables, typically one of them that has a higher power, and just kind of run with it. Okay. Number 18, your friend says that when subtracted polynomials, the order in which you subtract does not matter. Is your friend correct? Explain. In a nutshell, yes, it does matter in which order you subtract. If you're going, and it's really just a whole, like the whole idea of a subtraction, I guess, is 3 minus 9 is a lot different than 9 minus 3. So you need to go in the right order in order to make it happen. All right, that's it for this. Go ahead and check with your teacher on your assignment, and have a good day.